Microbial fuel cells, the energy of the future. But what is it? Well, at its simplest form, it's taking energy from cellular respiration of microbes and converting it into energy we can use.
Let's take a look at how it works on a mechanical level. This is what the machine looks like.
So now let's look at how it works. First, we must deprive the microbe of oxygen to ensure the energy from the cellular respiration sticks to the anode and not the oxygen atoms.
Microbial fuel cells were first discovered in 1931 by Baird Cohen, but until recently, it hasn't been widely used.
NEM Advanced Membrane Technologies is working hard in Spain to treat wastewater by using microbial fuel cells. What is interesting about their goals is that they are not concerned with producing energy, but rather aimed at the consumption of microbes in the cell's anode. They want to implement their cells in industrial and agricultural sites with wastewater streams. Their systems are robust enough to make them the perfect option for third world and other underdeveloped countries.
Well, if it has such great capabilities, why is it used? Well, it's a lot better than fossil fuels. It limited carbon emissions and will help aid in being able to provide green energy across the globe. But it is very expensive to run and make. Per unit of energy, it's a little less efficient economically than other green energy sources. It also would not help power areas with high electricity.
Along with this, there are very few operational units available, so a lot of work needs to be done. However, if we commit to this, we could provide energy across the world, even in remote areas, as all you need is a unit of microbes.
To explain how all of this works on a chemical level, we have to look at the chemical reaction. So what happens is glucose inside of the microbes are broken down into water, carbon dioxide, and energy. This is through cellular respiration. We take the energy from this equation reaction and convert it into energy that we can use in those batteries. So all we're relying on is the cellular respiration of the tiny bacteria in this system. All right, so it starts is back here. We have an air pump leading into the water right here, which if you look in there, you can see it's blowing some bubbles. It's kind of hard to see because it's dark. But inside there, we have the cathode. And then this connects to a wire, which comes to our first jumper cable. Then here is where we have this rope. And pretty much what it does is helps conduct the electricity between the two. It basically is completing the circuit.
Salt water.
And we soaked it in salt water too, which helps with the electrolytes and energy transfer. And then in here we have an airtight seal, or about as close as we can get, around this one, because this is the one with the sludge in it, which is basically mud from this swamp area. And what's going on is, since we're depriving this of oxygen, the microbes inside of this mud are doing cellular respiration, and that energy they create from that is then being trapped into the cathode, or the anode that we have within the mud, which is connected to this wire right here. And this wire runs to the jumper cables, so now that these jumper cables are connected, they can go on to go and charge anything from a battery to Noah.